Okay, so tonight we will cover prime and composite numbers. Objective is find all factor pairs for a whole number in the range of 1 to 100. Recognize that a whole number is a multiple of each of its factors. Determine whether a given whole number in the range of 1 to 100 is a multiple of a given one-digit number. And determine whether a given whole number in the range 1 to 100 is prime or composite. All right, so remember, a prime number is a number that cannot be divided by anything but itself and 1. And a composite number can be divided by more than 2 numbers. Okay, so you have prime numbers, such as 3, that can only be divided by 1 and 3. And then you have everything else. Like all the other numbers that are not prime are composite. So like 4. 4 can be divided by 1 and 4, and 2 and 2. All right, so here we've got an example of how to do that. So we have students are arranging square tables to make one larger rectangle table. If the students want to choose from the greatest number of ways to arrange the tables, should they use 12 or 13 square tables? So I'm going to find the factors. I'm going to basically build my tables here. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? My factors of that is 1 times 12. I can do 2's because it's an even number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? That makes a square. That's 2 times 6. I can do 3's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That makes a square. Actually a rectangle, sorry. But 3 times 4 makes 12. Okay, how about 13? So I have 3 possible ways with using 12. Let's try 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so that's 1 times 13. Can I do 13 any other ways? No. Okay, so then I have 1 and 13. So these are my factors. I have 1, 2, 3, 4, 6, and 12 for factors of 12. And for 13, I just have 1 and 13. So if they want to choose from the greatest number of ways, which number would they choose? 12. Good. All right, let's look at something else. Hey, prime and composite. So we're going to list factors of 11. I have 1, 2 can't go in, 3 can't go in, 4 doesn't go into 11, 5, it would have to end with a 5 or a 0, 6, nope, 7, nope, 8, no, 9, 10, 11. So it's 1 and 11. Doing it, yes. All right, how about 73? So I know I've got 1 and 73. Can 2 go into 73? It's hard to tell, so let's do division. 2 goes into 7 3 times. 2 times 3 is 6. 7 minus 6 is 1. 13. Can 2 go into 13? No, it cannot. Okay, let's try 3. So 2 can't work. Let's try 3. 3 will go into 7 2 times. 3 times 2 is 6. Bring the 3 down. Can 3 go into 13? No, it cannot. In fact, 4 doesn't, nothing in the 4's equals with the 3 at the end. But just to be on the safe side, 4 goes into 7 one time. 7 minus 4 is 3. Okay. 4 cannot go into 33. The closest is 32. 5 can't go in because it doesn't end with a 5 or a 0. 6. 6 goes into 7 one time. Okay. 6 can't go into 13, so 6 doesn't work. 7 won't work. Okay, to save you the trouble, nothing works. Okay, so 73 is a prime. So this one's prime. This one's prime. What about 69? I know 1 and 69 works. How about 2? Well, I know 2 has to be an even number. This makes it an odd number, so 2 ain't going to work. What about 3? 3 can go into 6 2 times. 3 times 2 is 6. Carry the 9 down. 3 can go into 9 3 times. Okay, 3 times 3 is 9. 9 minus 9 is 0. So it can go in 23 times. So 3 and 23. 4 can't go in because it needs an even number at the bottom as well. 5, it needs to be a 5 or a 0 at the end. 6 can't go in because it won't go into 9 evenly. And that is all. But it is a composite number because it has 1, 2, 3, 4 factors. Okay, 42. We have 1 and 42. It's an even number, so I know that 2 can go in. 2 goes into 4 2 times, and 2 goes into 2 once. 3 can go in, right? 3 into 42. Oops. Don't want to do that. Okay, 3 can go in 12 4 times, so it's 3 times 14. And 4 can't go in, 5 can't go in, but 6 times 7 works, right? Okay, so there's your factors. This is also composite because it has 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8 factors. Okay. All right, here's your homework. So for the first couple, you're just going to see if they are prime and composite. So 52 is an even number, so 2 can go into it. So that, I don't even have to figure out the factors. I know it's composite because it's even. 2 can go into 5 2 times, carry 1 over, they'll leave 12. 2 can go into 12 6 times. Let's see, 5 I know is composite, right? Because it ends in 5, it's a multiple of 5. All right, how about 87? 87. So we've got 1 and 87 for sure. It doesn't end in an even number, so 2 won't work. What about 3? 3 goes into 87. 3 goes into 8 2 times. 3 times 2 is 6. Oh, okay. So 3 can go into 7 9 times. Okay, so 3 times 29. I don't have to list all of them out because if it's got more than 2 factors, it is composite. Some of these you will actually have to work the factors out in order to find out if they're prime or composite. Okay, I'll leave the rest of them for you. Your WSQ for tonight is solve this riddle. I am a number between 60 and 100. My 1 digit is 2 less than my 10 digit. I am a prime number. Okay, so you're going to list the prime numbers between 60 and 100 and figure out if you can figure out this riddle. I will see you in the morning.